Let f of x and y equal x squared minus 2xy plus x cubed for all real x and y. Which of the following is true? And we're given five possibilities for statements of f. So with a question like this, I typically like to just go through the options one by one and either rule them out or confirm that they're true. But I will go through all 5 of these. Okay. First, f has all of its relative extrema on the line x equals y. So it seems like all the statements are about maxima or minima. Let's start by writing the function out, in fact, and then we'll go through the statements. This is equal to x squared minus 2xy plus y cubed. So since everything seems to be asking about minima and maxima, I think what I'll do is I'll just take derivatives of f. So partial of f in the x variable is 2x minus 2y. And the partial derivative in the y variable is equal to negative 2x plus 3y squared. Now, in order to have a minimum or maximum, we need both of these derivatives to be equal to 0. So let's suppose we set both of these equal to 0. This says that x is equal to y. And the second one says negative 2x plus 3y squared is equal to 0. This says 3y squared is equal to 2x. Or maybe it's a little easier to think about as y squared is equal to 2 over 3x. Now these are necessary for any point to be an extremum. This is necessary, but technically you have to do second derivative testing. So in particular, I don't think either of these is enough to give a minimum or maximum. I'd have to think about it a little bit more, right? If I suppose, because if x and y are both equal to 0, then these equations are satisfied. But 0, 0 well, let's see what the statements say. Okay. Statement A says that all of its relative extrema are on the line x equals y. So I'm not 100% sure what they mean by relative extrema. I think that probably means what I would call a local extrema, because they also, some of the other options say absolute, an absolute minimum. So this in fact does have to be true, because like we said, these are necessary conditions. So if a pair x comma y is a local minimum or maximum, then both of these equations have to be true. In particular, every local maximum or minimum will lie on this line. But let's go through and see why the other options have to be false. And maybe as I go through this, if I'm not sure, we can come back and check something here. So option B, it's the same thing, all relative extrema are on the parabola x equals y squared. So this is not going to be true. If this is the parabola that all the relative extrema have to lie on, yeah, so they just, it's the wrong parabola. That's not going to be necessary. So C, f has a relative minimum at 0, 0. This is not correct. If I simply let x be equal to 0, so that these two terms are gone, then the graph of f when x is equal to 0 looks like y cubed, and I of course can make f positive or negative or 0 or anything I want, right? So this is not a minimum, but that doesn't that doesn't contradict the first statement, by the way, because it's not saying that every point on this line is a relative extrema. It's just saying if you have a relative extrema, it must be on this line. So this is also false. Option D. F has an absolute minimum at 2 over 3, 2 over 3. This is instantly wrong. We know that instantly is wrong because I can make F arbitrarily large and negative. Again, if I just set x equal to 0, so these two terms disappear, I can make this last term as large or as small or as large and negative as I want. And so the same thing is true for the last statement, that f has an absolute minimum at 1, 1. That again is going to be wrong. I can make the function, it's unbounded above and below. So there in fact is no absolute minimum or maximum. Yeah, I mean, I guess the part of this problem that could get confusing is the understanding about when you take derivatives of a function of several variables and set them equal to 0. Those are necessary conditions for a particular point to be a local minimum or maximum. They're not sufficient conditions. So yeah, just understanding that, for example, 0, 0 is a solution to these two equations, but it's clearly not a minimum or a maximum. So you'd have to do more tests to actually figure out what is going on at that point in the function. Thanks for watching.